Hello guys and welcome back. This is the second video about finding drawing a scale. So if you watched the previous video, you know that we had a drawing with different views and maybe with different scales, and we wanted all of them have the same text size or the same dimension text height on everywhere be the same. Regardless of changing the scale, we wanted to have the same text height so everything be readable. If you followed the video before, you know that the problem was with AutoCAD. In AutoCAD, when you scale down a part, the objects, everything scales down, including text and dimensions. So as a result, if the dimensions and text are readable here, when you scale it down, they're not readable anymore. So as I said before, in this class, we're going to go with text size of 316, which is around 0.20 inches or 5 millimeter height for our text height. You may change it depending on the company or the industry that you're working for, because each company have their own standards. When we talk about engineering scale, we're talking about shrinking the views of, original views of, the full size views of any part to fit it on a drawing sheet. For example, in this case, this part, diameter of this cylinder is 3.5 inches. And now imagine, when you want to draw it on a size sheet, you cannot fit it. I decide to shrink it, make it half, and draw it here. So half of 3.5 is 1.75. So I'm going to draw a circle with diameter of 1.75, but I'm going to put the dimension as this much. Okay, so this is the scale. So here we call it a scale, 1:2, and the scale factor that I used here is 1 divided by 2 is 0.5. So basically, from this side to this side, from the actual part to the drawing, I have to multiply everything by 0.5 to draw the drawing. And what about the other way, from here to here? If I have the drawing here, and if I have a scale and I measure this diameter, if I multiply it by 2, which is inverse of this one, I'm going to get the actual size. So let's go to architectural drawings. Architectural drawings or civil engineering drawing or fire protection drawings are the drawings that we use different scale for them. The scales are usually like this. There is a fractional number equal to 1 foot 0 inches. For example, 332 inches is equal to 1 foot 0 inches. So always this side is 1 foot and the other side is a fractional number. What I mean by a fractional number is something like this. Just imagine length of this piece from here to here is 1 inch. If I divide it by 2, from here going to be ½ inch. If I divide that one again by 2, it's going to be quarter. From here to here is quarter of an inch. If I divide it by 2, it's going to be 1/8, 1/16, 1/32, 1/64, 1/28. So it's going to be like this. And now imagine you multiple any of those numbers that I just told you by 1, 2, 3, 4, 5, 6, and so on. So those numbers, we call them fractional numbers. So for example, here we can have 1/8, we can have 3/16, which is a little bit more than 1/8. You can see it here too. This is 1/8, and a little bit more than 1/8 is 3/16. So if I go back here, so I always have a fractional number here, and on the other side I have 1 foot. That's the architectural drawing scale. So what is application of this one? I just want to show you something here. Just imagine this is my drawing, and I know that my scale is 3/32 equal to 1 foot. So it means that if you measure from here to here using your scale, not by reading the dimension, okay? The dimension is precise. Just if you go from here to here and read the number here, by having this scale, you can find the actual size. For example, just imagine this is the garage, and you want to see width of the garage from here. You can just easily measure it using this scale, and by having this scale factor, you can find the width of the garage door. Okay, let's go back here and see that what I mean by architectural drawing scale and how we can find the actual size by having this architectural drawing scale. This was definition of architectural drawing scale. This is the way that we're showing it. I want to call this fractional number K. So A over B, I want to call it K. So it means that every K inches is equal to 1 foot, and 1 foot is 12 inches. So a scale factor is K divided by 12. Do you remember for the part that I just showed you, the mechanical engineering part, the scale factor was 1:2. In this case is K equal to 12. Why change this 1 foot to 12? Because I want both sides have the same unit. So in this case means that K divided by 12 is our scale factor. What was K? K was this fractional number, A over B. So it means that a scale factor is going to be A divided by B times 12. So let's give you an example. This is the scale factor of a drawing. This is the scale of a drawing, architectural scale of a drawing. 3/32 inches is equal to 1 foot 0 inches. And I want to find a scale factor. So this is K and this is 12. So K divided by 12 gonna be 3 divided by 32 times 12. So the result gonna be this much. Fine. Now the question is this: what about reverse calculation? How to find architectural drawing scale by having the scale factor? I know that it's a little bit, you have a lot of questions in your mind why I'm doing this, but bear with me, and in a few minutes you will see that why I'm doing this. So now just imagine that we have a number and that's our scale factor, and from a scale factor I want to find the architectural scale of the drawing. To do this, I show you an example here. This is the result of lab 1, okay? And in lab 1, you learn that we draw this, and this is done by Tim. So he drew this, and after that, he put a frame around it, which is a D-size sheet. So we're gonna go there in a few minutes, okay? So this is about drawing, and I want to have a frame around it, or sometimes people call it title block. I want to have a title block around this, okay? So this is the title block or frame. This is your Lab 2A project. So you're going to work on this one during Lab 2A. And you prepared something like this now. So I want to put this one around this. There are two ways to put this frame around this one. One way is that we enlarge the D-size sheet, which is very, very, very tiny comparing to this drawing, comparing to the building. Just imagine this is the full-size building, and that's a D-size sheet here. So one way is that you shrink this and put it here. Another way is that we enlarge this frame and put it around the building. In the videos that you watched, and Tim did it, what he did, he enlarged the frame and put it around the view. There is another way that we're going to talk about this one in CAD290, your next course. And that's using layout. You've probably seen layout by clicking on this layout here. You've probably seen something like this. We're going to do this in CAD290. If you go to Blackboard, you will see that I've provided you with some resources. If you are interested, you can watch those and you can learn it in advance. So I've done this here. This is the frame, and this is the view that I want to put it here. I'm not going to go through details, but I just want to show you that if I have the scale factor, how can I find architectural scale of a drawing? Now imagine I want to have this one on this sheet. If I zoom in and I see that, okay, for example, this much is good enough for me. This is a good scale. There is a number here that is changing. Look at this, by zooming in and zooming out. This is the scale factor. So basically, AutoCAD is giving you a scale factor in layout. Okay, so this is the scale factor. Let's go back to my presentation video. This is the scale factor. I know the scale factor, but I don't know what's the architectural scale of my drawing. So to do that is like this. I have to think what was definition of that architectural scale factor. This was the definition. I call this one K, and a scale factor became K divided by 12. Now I want to do it the other way around. So I want to find K. So I have the scale factor. So 12 times the scale factor gives me K. And what was the K? Was A over B. So A over B. So from here, I can find A over B. You found A over B, you can go to the chart and you can find the closest fractional number for that A over B. In my case, for example, for this number, is going to be 3/4. I have to stop the video here. In my next video, I'm going to continue this topic. Talk to you soon.